So I'm going to talk about some research that one of my PhD students has been leading. And one thing about this research is it's very interdisciplinary. So I co-advise this PhD student with a faculty in our department who's a mining engineer and data scientist. So don't ask me detailed questions about the methods. I'm just going to put that out there. But one reason why I think this research is important to talk about is because it really, all of the problems that we're talking about this week, in my mind, they require an interdisciplinary approach, whether it's an interdisciplinary approach from industry or academia. And so I feel like this research, our interdisciplinary team and our interdisciplinary approach sets a nice example for how we can be thinking about and working through these problems. So I'm going to focus on mine closure and why. And mine closure, so mines close when the ore deposit is no longer economically viable, or there's some other external reason, perhaps social conflict, etc. So mine closure is rated among mining's top operating risks, and I'm sure many of us have heard about the boom-bust cycle. So when a mine comes in, there's jobs, there's economic opportunities. When the mine leaves, those jobs go away. Oftentimes, the economic opportunities go away as well. So mine closure regulations have mainly focused on the environmental and physical aspects of mine closure rather than the social aspects. And only a few countries or provinces or states have enacted and executed specific mine closure laws and regulations. Most of this is within the mining law or within broader environmental regulation. However, in recent years, international best practice guidelines have paid more attention to mine closure. And so we see the ICMM, which is a big global industry organization, released closure guidance in 2019. And really they emphasized this integrated mine closure. So a disciplined approach to integrating mine closures. So delayed closure planning, which has happened historically, can reduce repurposing alternatives, and it can rush the evaluation of best alternatives for mined land when it's done being mined. And supporting sustainable development is a critical issue, and that's raised in the integrated mine closure document. So early definition of the closure vision, according to the ICMM, would include consistent and transparent stakeholder engagement, which I know we've talked about this week so far, community participation in planning, and then it allows for often better social transitions, more accurate cost estimates, early identification of risks and mitigation strategies, and a progressive reduction of liabilities. So the case study that I'm talking about is Henderson Mine, which, Michael, you're familiar with. This is run by Freeport-McMoRan. It's 68 kilometers west of Denver. So in this, here you see Colorado, central United States. There's the Henderson molybdenum mine. Molybdenum here, goes into steel. I'm sure our geochemists can tell us more details about molybdenum. But here we have Denver. And Denver's located right about here. So here we have Denver, and then we just go up I-70, and here's the mine. So it's in a mountainous region, very beautiful area. And a background to the site, in 1964, the ore body was discovered. Shaft sinking began 4 years later. Production began in 1967. And the mine underwent a large modernization project that was completed in 1999. And within the next 20 years or so, closure is expected. And roughly the mine produces about 18 million pounds of molybdenum a year. And the total land that the mine and the mill site and the tailings area encompasses is about a little bit more than 5,000 hectares. So in this study, and I'll tell you a little bit more about the scope of the study, but we focused on the mill area of the site. So this is the mill area of the site. It's where they mill the molybdenum and where the tailings are deposited. And so this area is about 24 kilometers west of the mine itself, and it's an underground mine. And it includes about 566 hectares of tailings. And the mine contributes a lot to the economics of the area. That provides over 350 jobs. Local tax contributions, you can see in 2017, 2018, multi-million dollars in taxes, and expected to contribute more, or contribute taxes over the next 7 years. However, the pending closure of the mine has raised a lot of community concerns. So this is an article from 2015, so a number of years ago, but looming Henderson mine closure stokes big fears in Clear Creek County. They have been a great place for my husband to work. We raised our 4 kids with him working up in the mine. They provided for us. And then someone else's husband has worked as an electrician at Henderson for 5 years, and while they are hoping he will make it through the January layoff, she called it a long shot. I can't believe it's closing, the Idaho Springs resident said as she left her job at a diner in town. We just bought a house. So significant potential economic impacts. So what our study was Freeport-McMoRan has sponsored student challenges at our university for the past couple years. And in a few years ago, I think it was 2019, they sponsored a challenge for students, teams, to come up with post-closure repurposing alternatives. And so the winners of the challenge, so students worked in teams with faculty and industry advisors, and the winners of the challenge, chosen by the judges, were glass manufacturing from tailings. So this was to repurpose the mill and tailings site. So glass manufacturing from tailings, organic shrimp farming, and then CBD and hemp production. Does everybody know what CBD is? Yes, okay, I hear laughs and, okay. So Colorado, it makes sense, right? So what we did was we wanted to understand if these options that the students proposed were sort of the right options in terms of sustainable development. And we wanted to understand how different stakeholders envisioned post-mining repurposing, and we wanted to see if we could quantify that. Because something that I think we run into in the mining industry is being able to quantify some of that social science. So instead of being accused of being the social scientists who are just hand-waving, we really want to be able to translate our data into numbers and figures that our engineers can understand and wrap their heads around, and that makes sense to them. So what we did is we wanted to evaluate each scenario's contributions to sustainable development and identify the strengths and weaknesses. And we wanted to investigate the most important aspects of sustainability to different stakeholder groups and determine which proposed repurposing plan resulted in the most economically, environmentally, and socially sustainable outcomes. And so we took these student projects, and here's our methodology. What we did is we gleaned, well, I'll go through this in a little bit more detail, but first we did an indicator selection process. We collected our data, and then we did multi-attribute decision analysis, and we assessed our results. And I'm going to go through this in a little bit more detail. So our indicator selection, so indicators are published by, here we have the GRI, which is the Global Reporting Initiative. So they publish guidance for companies, any kind of company, of how you can measure your contributions to, or you would measure your emissions through there. You would measure community engagement. So that they're measurable indicators are things that you can use to measure progress or measure some kind of benchmark from. So we gleaned a list of 230 indicators from all these different sort of reporting frameworks and from the scientific literature as well, and broke them into 3 subsets. So environmental indicators, social indicators, and economic indicators, recognizing that there's often overlap between these. And we looked at the student reports and we got information from the mining company, and we refined this list to 17 indicators because we could really only assess what was in the student reports, and I'll come back to that at the end. So this is our list of indicators. I'm not going to go through this in any kind of depth, but we have economic and social, and so we crafted a survey that had, and we used different verbiage in the survey just to make sure it was understandable to everyone who took the survey. And here are environmental indicators. And so keep in mind, these are things that appeared in the students' reports, so we could actually glean information from them. And here we collected data from the mining company and the student projects, and we created a stakeholder survey. We were doing this during COVID, so everything was online. And we identified 7 stakeholder groups. We received 41 complete responses, and we completed an analytical hierarchy process to determine the weights. So here's our stakeholder groups. And first we have government agency. This refers to state government, representatives from the mining company, local nonprofit organizations. Faculty members were faculty members of the Colorado School of Mines who advised the student groups. Local government is city and county officials from the areas that would be impacted by the closure. Community members, and then industry advisors. And industry advisors were also advising the student groups. And so, these just show the numbers of responses we got. So pretty low ends. You know, if you were really doing this in real life, you definitely would want a much greater sample. And then we did multi-attribute decision analysis, and this is where that interdisciplinary twist comes, where don't ask me many details about the algorithms and things. But no less, we divided them into, you see we have our economic, environmental, and social categories. And then we broke these down into another level 3 attributes. So here, if we look at social, we have community impacts and employment. And then this is our level 4, the actual indicators. So under community impacts, we have nuisance and risks, road use and traffic load, employment, average annual salary, number of different job types, number of employees. So at each level, they get more specific. And then step 2, we formulated utility functions. And so this is using logical decision software, and we assumed linear single measure utility functions. And so the purpose of this was to basically try to identify which design was the most useful to particular stakeholders. And we did, step 3 was the weighting preferences, where the survey results revealed the weights. So the importance of attributes. So in the survey, we asked respondents to say, what's more important to you? Or what's more of a priority? Nuisance, traffic, or waste production. And so we had them rank those and then used this, the MADA to assess those and analyze those. So in terms of the results, and I'm not going to go through these all in great detail, but here we have the 3 main categories: environmental, economic, and social. We see economic in blue, environmental in green, and social in yellow. And here's all our different stakeholder groups. The end of each of these graphs I'm going to show you is the combined decision. And so overall, the different stakeholder groups, we see here that local governments, community members, government agencies, and industry advisors prioritized the economic indicators more so than the other indicators. While faculty members, the mining company, local nonprofits, they prioritized the environmental more. At this level, nobody was prioritizing the social indicators as much as the others. And then the combined decision we see mirrors those of the local governments, the community members, the government agencies, and the industry advisors. When we dive down a little bit deeper, let's look at the economic criteria. And here we go down remember the levels I showed you? Here we go down 1 level. So we see contribution to society in blue, where it was investments in infrastructure and public services and income tax. and economic performance, which would be the production capacity, the revenue, and the time until full production. So this is for these repurposing strategies that the students proposed. So here we see the combined decision. Overall, the priority among all the stakeholders was contribution to society. And this is mirrored by community members, local nonprofits, the mining company, and the faculty members. Whereas the economic performance was prioritized by the industry advisors and then the two different government agencies. Some of these results are fairly intuitive, I would say. Here, when we drill down another level, so this is our contribution to society category, so they were prioritizing income tax payments or investment in public services. And we see here that the combined decision prioritized more investment in public services. And that was mirrored by community members, local nonprofits, the mining company, government agencies, and faculty members. Whereas income tax payments were more valued by the industry advisors and then local governments, which makes sense, right? Local governments would benefit more from those tax payments. When we go to economic performance, we see that here it's revenue, time until full capacity, and production capacity. The combined decision prioritized revenue. They actually, all of the stakeholder groups, except for the faculty members, prioritized revenue. Faculty members seem to prioritize the time until full capacity. So time until the factory or plant or whatever production was at full capacity. For our social criteria, we have our community impacts and employment. And here employment was prioritized by the combined decision, mirrored by local governments, community members, mining company, government agencies, industry advisors, whereas local nonprofits and faculty members prioritized community impacts. And then when we, again, drill down into community impacts, we see that nuisance, which would be like noise, mostly noise, and traffic, we see that nuisance was prioritized, and we see that mirrored by the community members, the local nonprofits, the mining companies, the industry advisors, and faculty members. So what we're seeing here is we're not really seeing all that much alignment in terms of how the different stakeholders view these things. You know, there are different groups kind of grouped differently according to what the indicators were. When we look at employment, we see here that annual salary was more of a priority than the number of employees and the number of job types. And this is mirrored again by local nonprofits and the mining company and government agencies. Whereas the number of employees was more of a priority to local governments, community members, industry advisors, and faculty members. And we kind of kept going. We'll get to, I'll do a couple environmental and then I'll get to the results, the real results. So here we have environmental criteria, but a lot of you are interested in this. So our combined decision, air pollution was more of a priority than waste that the new facility would generate, resource consumption, and then land use. And we see that mirrored pretty much by local governments, but also by community members, government agencies, industry advisors, and faculty members. The mining company was pretty similar, just a little bit of variation here, and then the local nonprofits had variation there as well. And I can make these slides available too, so we can go through those, or you can go through those. In the end, do you remember what was number one? Do you remember? Glass. What was number two? Shrimp. And three? CBD. Okay. So here we have the different stakeholder priorities. And for community members, shrimp won out. And you can see the different contributions that it made to different parts of economic, environmental, social. Here, the mining company, shrimp, won out. Local nonprofits, the same. Faculty members, the same. Industry advisors, local governments, and government agencies, however, prioritized tailings. And we see that the utility or the weights given to the different categories shifted. So overall, shrimp won, according to our assessment. And then hemp, and then tailings. So pretty much not exactly what the judges had decided. And here we see how those are weighted. So shrimp, there was more value or more priority here on the environmental aspects of the shrimp farming, and with hemp. But tailings, you can see it had more economic advantages. We also looked, and this is crazy looking, I know, but we also looked at the variation within the stakeholder groups. So you can see the different levels. Here, it's easier for me to look over here for some reason. So overall, the different perspectives within each stakeholder groups increased from levels 2 to level 4. So here we see level 2, economic, social, environmental, and here we get more detailed. And the sort of the disagreement within groups increased as the indicators became more specific. And we see some trends here. We see there was greater alignment at level 2 within each group on the importance of the social sub-goals. So we see the green means greater alignment here on social sub-goals. And at level 3, there was greater alignment on the importance of the environmental criteria. So here's all our environmental criteria. So more agreement within stakeholder groups. At level 4, the respondents within each stakeholder group were most aligned in their prioritization of the economic aspects. So here's level 4, economic. We see it's slight, but slightly more green there. And then overall, local nonprofits. So here's our column of local nonprofits, going down here. And the mining company here had more agreement, which makes sense because if you think about local nonprofits and a mining company, people come together under a particular charter in those organizations. Whereas there was much more heterogeneity within the community members, within the, mostly within the community members, we see, where is it? Here we go. Much more heterogeneity, which speaks to the heterogeneity of communities, right? And so what we found overall was that the judge's assessment did not reflect the stakeholder preferences, and that the ranking of alternatives, as I pointed out, changed based on the stakeholders' preferences and values. And so we found that stakeholder groups shared both similar and different priorities, both within their groups and across the groups. And each alternative had its own strengths and weaknesses. Remember how I pointed out that some were more, one was more environmentally prioritized or contributed more to environmental indicators, and the others were more economic. Overall, the combined group prioritized economic than environmental than social, and community members' views generally were in line with the combined group decision. So that, again, reflects that heterogeneity of communities. Local nonprofits and the mining company had the closest views among their members, while local governments and community members had the greatest diversity. And one significant limitation of this study was that only a small set of indicators could be selected because we were gleaning them from the students' reports. So therefore, what we would suggest is that in the next iteration of a student challenge, that a wider range of indicators should be used. And so the student reports would be more robust. So that's what I have for you today, and I'm happy to answer any questions.